Welcome to the screen printing training video. In this video, we'll cover a high-level overview of how screen printing fits into the overall SMT process, why this step is so critical, and how early decisions affect everything that follows. This is not a step-by-step setup video yet. The goal here is to build the right mental model so the settings you enter later actually make sense. Screen printing is the first manufacturing step in the SMT process. Every process that follows, including component placement, reflow, inspection, and test, depends on this step being done correctly. If solder paste is not printed correctly, the rest of the process is already compromised. No amount of placement accuracy or inspection can recover from a poor print. By the end of this video, you'll understand why screen printing sets the foundation for the entire SMT process. Before we talk about the printer itself, it's important to understand that print quality starts before the machine is ever touched. Good screen printing begins at the engineering stage with proper stencil design. Stencil thickness, aperture size, aperture shape, and segmentation directly control how much solder paste is deposited on the board and how well that paste releases. If the stencil is designed incorrectly, no amount of printer adjustment will fully correct the problem. That's why aperture design should be based on component manufacturer data sheets, recommended land patterns, and proven design guidelines. Using the correct aperture reductions and stencil thickness helps ensure the correct solder volume the first time. When tools like Valor Process Prep are used during DFM, engineering can evaluate aperture design early, reduce risk, and avoid trial and error adjustments on the production floor. The goal is simple: design it right so production does not have to compensate later. This becomes especially important on dense, high-value assemblies. For example, some boards contain 24 DIMM sockets. Each socket has 288 solder joints, for a total of 6,912 solder joints on a single board. Because the spacing is so tight, even one solder bridge can make the board unreworkable. That means a single screen printing defect can result in scrapping a $5,000 assembly. This is why stencil design, setup discipline, and correct data entry matter so much. The screen printer works in a specific order. Each setup step depends on the previous one being correct. If an early step is wrong, the printer can still run, but it will run incorrectly. Think of the printer as solving a problem in this sequence. Where is the board? Where's the stencil? How do they align? And how should solder paste be applied? Once you understand this flow, troubleshooting becomes much easier. At a high level, every screen printing job follows the same workflow. First, the machine needs to understand the PCB and panel information. Second, it aligns the board to the stencil using fiducials. Third, it verifies print parameters like squeegee pressure and speed. Finally, it prints solder paste and checks the result. Most printing problems trace back to one of these stages being skipped, rushed, or entered incorrectly. In SMT, quality confirmation happens through process verification rather than added inspection steps. After screen printing, solder paste inspection, or SPI, is used to confirm that paste volume, alignment, and deposit quality are within control. The goal is not to inspect defects out later, but to verify that the printing process is stable and producing consistent results. Catching variation at this stage prevents defects from propagating downstream into placement, reflow, and test. This early confirmation protects both quality and throughput. In this video, we covered why screen printing is the foundation of the SMT process, why print quality starts before the printer, and how early decisions affect everything downstream. In the next video, we'll go deeper into how the printer uses PCB and panel data, and why getting that step right prevents many common printing errors. Thanks for watching.